Good morning all. Hopefully the party last night didn't hurt you guys too much. Okay, I'm Brent Morgan. I'm a Flutter Developer Relations Engineer, and it's time to do the audience participation part of the talk. Please raise your hand if you have Flutter already installed. Okay, that's about half of you. For those of you who don't, I suggest you go and find someone who has Flutter installed, because downloading all the tooling, the Android tooling, the iOS simulator, the Android emulator will take a little bit long. So if you team up, this will be a whole lot more fun for you. Okay, what we're going to be working through today is this code lab. So if you go to docs.flutter.dev/go/Forge2D workshop, it's okay. You don't need to panic about that URL. It'll be on every page. You'll come to a page that looks very much like this, that has the text of the code lab, and what I'll be doing is walking through the steps of this code lab. So, as you can see, URL's right up the top, and the step that I'm on right next to it. Okay. I'll give you all guys a sec or two to get started. Okay. There's a fair amount of content here, so I'm just going to get started. So the first steps of this code lab are creating a Flutter project, Flutter create --empty Forge2D game. Now, you don't have to do it that way. Most Flutter IDEs have an in-IDE way of starting a project, but need to pick one way of doing it, and I went with the command line. The --empty is a neat little thing. It basically strips down the amount of boilerplate in the code. You don't have to worry if you don't use it. We're just going to overwrite the boilerplate anyway. The next thing to do is to add some dependencies to our project. We're going to add, using Flutter pub add in this example, characters, Flame, Forge2D, and XML. All of those will become useful at some point in the code lab. Once you've run those 3 commands, or done the equivalent in your IDE, you'll be able to open up the pub/spec YAML of your project, and you should see something like the following. There will be additional comments in here if you didn't do the --empty. So the first one, characters. Characters is a really useful addition. It does proper handling of UTF-8 for file handling. I put this in purely so that if you're consuming XML or files that have things that are outside of ASCII 7, you'll do them correctly. The next one is Flame itself. This is a code lab written for the Flame game engine. Next one, Flame Forge2D. This is the adapter for Forge2D. Forge2D is a Dart of Box2D. Box2D is a really great piece of gaming history. It was the first 2D physics and simulation engine, and it was originally written in C++ and then ported to pretty much everything. Dart's Forge2D engine is actually a port of the Java Box2D library, which itself was a port of C++ one. So nothing like a good bit of genealogy there. And lastly, XML. I know it seems strange to have XML dependencies on a game, but turns out the assets we're going to be using today come with a whole bunch of XML, so we're going to need to be able to parse the XML to make use of them. Okay, and here is your first game. What we're going to do is we're going to take the standard Flutter app and replace it with game widget controlled. This is a widget that turns around and manages a Flame game instance, which is this guy. This is using the tear-off constructor notation, so Flame game new. It turns it into a callable that game widget can then use to construct your game. And if you turn around and run that, you should get something like this. The world's most boring 60 frames per second game that you've ever seen. So I'm going to hold here for a second and let you guys cut and paste your way up to this point. If you're getting stuck at any point, please feel free to raise your hand. Craig up the back is waiting on tenterhooks to answer your questions. Okay, got a fair amount of content to get through today, so I'm going to have to push ahead. Okay, the next thing I'm going to get you to do is download some assets. So if you go to kenny.nl/assets/physics assets, you will see a page by world-renowned graphic artist, Kenny. He's basically a legend in the gaming community. He creates CC0 assets that game programmers everywhere use to get started with building their games, and you too will now fall into this category. If you download the art pack on that page, you'll get a whole bunch of images, way more than you're going to use. I'll show you in a second how we're going to selectively pull images and XML files out of that asset pack and put them into your game such that we can get a game going. Okay. This is what you're going to wind up with. You're going to create a directory called assets, and within that, a directory called images. We're going to have 4 backgrounds, so colored desert, colored grass, colored land, and colored shroom. We're actually only going to use one of them, but I thought all 4 of them would encourage you guys to build additional levels to your game. The fun thing to notice here is these images are actually square, and that will become useful in just a moment. The next thing we're going to introduce you to are sprite sheets. Back in the good old days, back in the 70s and 80s when I started gaming, computers were a lot smaller and a lot slower than they are today. So one of the optimization tricks that we used to pull was that you'd have a game with lots of small art assets, and you combine them together into a single file, like say this, so that the computer had less work to do. It could load one image and then cut little bits of it out to put them on the screen. And this technique was called sprite sheeting. So this game engine, quite thoughtfully, makes it really easy to do this technique. And finally, some tiles. We'll actually use 4 of these, but we've got coins and stars and flags that you can add later on. Okay, this is the XML file that goes with the first sprite sheet I showed you, the aliens. To give you a hint as to how to read this, if we're interested in pulling out the alien blue round.png from this sprite sheet, what we need to do is look at the location 280 by 70 and look for a 70/70 slice, and that gives us that specific part of the image for that individual art asset. So obviously, to be able to use this sprite sheet, we're going to have to write some XML parsing code to actually pull all this out, which we'll get to momentarily. And I did show you the one with lots of stuff in it. That one's going to need some help, and you'll see in the code lab when we get there how that's done. And finally, these are the 4 tiles that we're going to use for the ground. Now, the next thing you do, you've added the images, you've added the XML into the specific directory, but for them to be available to your program at runtime, you need to make a change to your pubspec.yaml file. You need to add an assets key to your Flutter key inside of your pubspec YAML, and add -assets and assets/images/. These two by having the assets /, it's effectively saying all of the files directly in the assets directory will be included, but not recursively, which is why you need to name the individual directories. You can also name individual files here if you want to not include some assets, but given the fact that all the files that we put in the assets and asset image directory we want to include, this shorthand is good. Oops, too far. So, time to introduce you to components. If you've done any Flutter development up until now, you've heard the saying, everything is a widget. And now we're going to go ahead and break that. Inside of Flame, we don't use widgets, we use components. For those who've done a lot of Flutter development, you've probably heard of a thing called a render object. Components are very much like a render object with a heartbeat. And I'll show you what I mean in probably 5 minutes. So we're creating a class called background that extends sprite component. Sprites should sound familiar given the fact we're just talking about sprite sheets. But let's talk about components. For us, this component means we have the ability to have sort of callbacks from the runtime. In this case, we're going to use onMount. And that will be really useful because we want to size the thing. And sprite is effectively an image of some sort. These ones are going to be our background. So we're going to say this is a dependency. We're going to wire that straight through. We're going to take a handle on it right in the center of it. So anchor.center. And we're going to position it in the middle of the screen. Why do I say it's in the middle of the screen? I'm relying on the fact that the screen is going to be, the 0, 0 point is going to be the center of the screen, which we're going to accomplish in the next slide by setting up how our camera works. By doing that, we have the image centered, but what we want to do is make sure the background covers the whole screen. How do we do that? We've got this lovely little mixin called hasGameReference. And because this component will be a child of the game, indirectly, we need the ability to reach up to get the game so that we can ask it how wide it is and how high it is, so that we can get the maximum and effectively do the same as box fit cover. We change the size of this component to make the game's rendering size, and there we get full screen coverage, full bleed. Now the game itself. It's in the components directory because Forge2D game extends Flame game, which indirectly extends component, and also it maps nicely to my brain. It's a special type of component with extra features. This is, we're passing through parameters to our super. Gravity's a fun one. It understands why it's 0, 10. Here's where I can tell the difference between Americans and everyone else. Those of you who come up like I did in the MKS system know that 9.81 is approximately the force of gravity. 9.81 meters per second. For Americans, 32 feet per second. That's the equivalent. So what this is telling us is that in Flame Forge2D, the increasing Y direction is down, which may take you a little bit to come to terms with. It's actually related to CRTs. If you want to talk more about that, happy to chat afterwards. The other thing I mentioned is that 0, 0 is the center of the screen, and how we accomplish it is a component with fixed resolution. I've gone old school here, back when I had a computer 20 years ago when these sorts of games were first coming out. They were 3x4, and they had not very much in the way of resolution, so as a callback to that, I've gone with 800x600. Those of you who have grey hair like I do will understand why, and everyone else will go, they made monitors that? Yeah, okay. Keep going. Okay, so this too has an onload method. This one is set up primarily for loading assets. We're going to, of course, async, so because dealing with disks and network is slow, this is going to be asynchronous. If you've done any Flutter development, you will have seen root bundle load string before. This is how we load in our XML files, all 3 of them. But the fun one is this one. This is effectively the same thing. However, it's actually using a capability of the Flame game engine itself, where it will actually cache the images you load. So you can load them multiple times, and it will do it just the once. I'm just doing it the once here on load because, well, I need it for the whole thing, but it's there if you need it. So we load in 4 of them. Now this is an extension. This is fun. It's an extension method on list that will turn, in this case, a list of futures into a future list, which means we can await the one thing and then do a destructuring assignment to pull out the individual components once they've actually loaded from disk. So now you have enough knowledge to understand what this code is doing. We're creating the background component, which I just showed you, and we're handing in the background image we just loaded from disk, wrapping it with a sprite. So on one hand, in Flame, sprite is effectively an image wrapper, but it has another trick up its sleeve, which I'll show you in a second. The next thing I'm going to harp on about is world.add. The number of times I have lost half an hour of my life by forgetting to do world.add here, and instead just adding components directly to the game. The problem is, if you add a component directly to the game, it won't be translated or modified by the camera. It will just be sitting around in screen view space, which is not good if you want to be able to, move around the screen or do something like that in your game. It's great if you're writing, say, a heads-up display, where you always want that component to be, top dead center or bottom corner or whatever. But everything else, you need to add it to the world, especially if it is, say, a Forge2D body component, which we'll get to in the next section. You really need it to be in the world for Forge2D to be able to see it and simulate it. Okay, I showed you the XML sprite sheets before. Here's how we deal with them. We're going to build this object. It consists of two things. One is the image that we've loaded off disk. And the second is a list of, a map from name to rectangle. This is that mapping of saying, okay, this sub-image is at this location and it's this big inside of the sprite sheet. So how are we going to do that? We're going to parse some XML, those three XML files I showed you. We're going to look inside them using our friend the XPath. Those of you who did XML back in the 2000s will understand what XPath is. For everyone else, think of it as SQL XML documents. This case, it's a simple path in where we're saying, for the texture atlas, I want all of the subtextures. And it returns them as a list, so we can loop over to them in a for loop. And we can pull out the attributes. We're looking for X, Y, that's our location in the image. Width and height is the size of the sub-image. And with those, create a rect, which populates, and now we have the ability to get an individual sprite from the image, which shows you a different version of sprite. This time it's a sub-image inside of the main image. So sprite is doing dual duty for complete images or sprites, which is thus its name. Okay. With this, we have one more change to make, which is to import components game into our main.dart and replace the Flame game that was there previously with my physics game that you just created. And if you run it, you'll get this wonderful thing. And I'll hold for a couple of minutes to let you, hold for 30 seconds to let you catch up. Okay. I'm going to push on. Fair amount of content, yada yada. Okay, so we've seen one component. Time to find a new component. This one is going to form the basis of our whole game. It's going to be quite literally the ground layer. This one, you'll notice as a pattern in my code, is I tend to leave things that I want to play with up the top as a configurable, which is, in this case, ground size. If you remember, the sprites for the ground was 70 by 70. The reason this is 7.0 is the Flame Forge2D. If you have a look at it closely, it's actually zooming in by a power of 10. So now these things, instead of being thousands of pixels, are now tens of units. And that's important for Forge2D. We don't want anything too big for Forge2D because otherwise the mathematics of the Forge2D simulation don't stop working, shall we say. They run out of precision. So it's a body component. This comes from the Flame Forge2D package. And we have a sprite. We know about sprites. We covered that previously. So this is the same as before. But the important thing to notice here that the sprite component is actually a child of the body component. Yes, you can have trees of components. This is useful for things like, say, wheels on a car or arms on a person, those sorts of hierarchical relationships. But from the point of view of Forge2D, only the top level ones are entered into the Forge2D simulation. So the body components have to form the top layer of your game and everything else can hang off underneath it. The other thing I needed to point out here is sprite component is doing our painting. So I need to turn off the debugging render body. But however, while you're doing your initial development, feel free to take this line away and just write directly with Forge2D and have it display its debugging display. And that way it's easy to do development while you figure out the size of things and how things react. The next thing I want to talk about is position and how we get that into the game engine. So we have a body def. This is the definition of a body. So in Forge2D, you have bodies and you have shapes, and what joins them together is fixtures. The body is effectively a point in space. This is the center, the pivot point, if you will, for the game, for the Forge2D simulation. And we're saying it's a static. So in Forge2D, body types come in three. You've got static, which are both infinitely heavy and weightless. What do I mean by that? They're infinitely heavy in that you can hit them with absolutely anything and they will not move. But they're weightless in that you can put them in a gravity field and they don't fall down. They just float around like bricks don't, in reference to an old sci-fi author. The other half I said was shapes. We're going to have a shape. It's going to be a box. X, Y is there because this is an axis-aligned box. There are set as box without X, Y, and they can be rotated. But these X, Y ones are just X and Y. The reason that we're making it ground size divided by 2 is that if you have a look at the documentation for set as box, it takes the width and height as half. Why it does that, I blame Box2D. Fixture def, so this, each body can have multiple fixtures, so it can have multiple shapes attached. This is useful if you want to, say, attach skids and other areas to a body and have different parts of it react differently, but we're only having one shape per body, so there's only one fixture def, but it's a really useful place to, say, add friction to it. So your game needs some friction, otherwise things just slide around like they're on ice, and that doesn't look nearly as much fun. What we're going to do now that we've created the ground component, is we're actually going to get it into the game. So what do we need to do for that? We'll have to import it into your game, and then to the onload method, just to scroll up. We're sitting here in the onload method. We call add ground. We await it because it takes a little bit of time to do these things. And what we're doing in the definition of add ground is we're doing world add all. So this is different from world.add in that it takes a list of components, and because we're inside of a list, we can do a for loop. Yes, we can do for loops inside a list. For those who are new to Dart, this is one of those fun things that we can do. What we're going to do here is we're going to start at the left edge of the game, and while we've not made it to the right side of the game, we're going to go across by one of these components. And what we're going to effectively do is lay a line of ground components as if they were bricks in a wall. This technique is useful in that this will adapt no matter how big or small I make the game, even though I'm using a fixed rendering size. I didn't know that when I was writing this code. And it means you can change the other codes and it will just adapt. Which means, once you run it, you'll get something like this. You've got the background there, and you've got a list of ground components in front of it. And that's what everything will bounce off. I'll just hold for 30 seconds and let you guys catch up. Okay, pushing on. Okay, now that we've got the ground across the bottom, let's have some stuff that moves. We're going to have another component, again with my usual fun and games with a twiggleable at the top. We're going to have a set of bricks. Bricks come in types, so we're going to have a type. This is an enum where we have the different types. We're going to have different density and different friction. The density is effectively a way of saying how much this thing weighs. The friction is how much something slides across something else. So thus I have things like stone having much higher friction than something like glass. This is how we do construct an enum type with values attached to it. And this is a helper static type that allows us to effectively ask for a random type of brick and do the same with brick size. So we've got a bunch of different sizes. If you remember back when we saw the image, there were small bricks and big bricks. These are the ones that I felt useful. And they come in different styles of damage. This is here so that when you extend this game, you can turn around and give your bricks hit points, say, so that when they get hit, they degrade until they disappear. I don't have that code in this code lab yet, but it was already oversized, so I had to stop. Now here's the fun part. Remember how that sheet had a whole lot of entries, that huge XML file? In the code lab itself, I actually write the command line tooling to generate the code you're about to see, but it's also here, so you don't need to actually run the code. You can just cut and paste it, and there it goes. Yep, that gives me... Anyway, the brick itself. It's another body component. We've seen this before. But what's different this time? Well, firstly, we have a bunch of attributes because we have as we saw above, the enums for brick size and damage. The damage itself is modeled as being mutable, i.e. you can damage a brick. I don't take advantage of that, but I've left it here so that you can add that capability to your game when you build on further from here. We have a sprite component because we need to be able to deal with the fact that sprite needs to change as the brick gets more damaged, which is why it's in the onload method so that we have a handle on it. Next thing we're going to do is we've got a body def. This is the same as before with one slight change. We've gone from body type static to body type dynamic. That means that this thing moves. So I don't remember if I explained what the three types were. Static, dynamic, and kinematic. Static is the one that stays no matter where you put it. It doesn't move. Dynamic is fully simulated. So you put it in the game engine, it reacts to gravity, it bounces into other things. Kinematic is a different beast again, and it's not in this, again, it's beyond the extent of this tutorial. Okay, moving on. I've got density and friction being dependent on the type of brick it is. So if you have glass or if you have stone, it will react differently in the game. We need to add this to the game itself. So again, we start by importing it. We add bricks to the onload method. This time I'm using unawaited as opposed to await. Why am I doing that? Oh, let me show you a little trick. So we have the add bricks definition here. What we're going to do is have a for loop. We're going to add 5 bricks. We're going to randomly select the type and size of the brick. We're going to add the brick itself. We've seen most of this before. The only tricky bit is that we're randomly positioning the bricks. This is both for visual sanity, but also as an optimization. If you instantiate a lot of objects at the same point inside of Forge2D, it gets a little bit upset because it has to push everything out of the way because it can't have objects overlapping. So you'll have a CPU usage spike in that case. So I've made sure to space things out a bit to give the game engine a little bit of an easier time. So once we've added it to the world, I effectively do a sleep. So this is why it's unawaited, because I effectively want the game to continue on, even though I'm making the bricks appear after the initial frame render, which is what you can see here. Bricks coming into existence one after the other. And I'll hold here for 30 seconds and let you guys catch up. Okay, now the fun part. It's much more fun to have a game when you have a player in it. Just watching bricks fall out of the sky is not as much fun as being able to throw something at the bricks. So let's implement that now. Okay, we have another twiggleable. You'll notice this is slightly smaller. So even though everything was 70 by 70, I just felt that the player needed to be a little bit smaller, taking into account that he's round, not square, and a few other odds and pieces. These sorts of things that you get to twiggle are part of being a game designer. You get to play them and go, I'd rather it if it was bigger or smaller. So making things configurable like this will make your life a lot more fun. If you remember the aliens sprite sheet, the aliens came in 4 colors. So the player is going to be one of 4 colors. And the player himself, also a body component, but it has an extension, another mix-in, drag callbacks. This is here so that we can actually influence where the player goes. We'll effectively drag on the player and have him shoot off in the other direction. This part here, where we've got a body def and a circle attached to him. So previously we had axis-aligned boxes. This one's different. He's a circle, or she's a circle, take your pick. The primary fun part here is that the player starts off as static. Why am I doing that? Well, I just want him to be on the screen in a known location, and then you drag, and then you release, and that's when jumps into action. So how do we do that? We need a sprite, obviously, for showing. Why am I doing that? Well, I'm actually not doing anything massive with the sprite itself, but I need to be painted on top of a custom painted component. So effectively, in Flame, all the components are painted in what's called painter order, i.e. things that are added later are painted later. So if you can effectively order how things are painted by how you construct your trees. The custom painted component, this is actually effectively a callback to the world of Flutter in that it uses a custom painter, which we'll get to shortly. And this is, I mentioned before that components are effectively render objects with a heartbeat. This is the heartbeat, this is the update, this is called every frame, telling you how long since the last frame. And what I'm using this for is to do a couple of things. When you flick the player across the screen, he could wind up, or she could wind up coming to rest and just sitting there doing nothing. If that's the case, the Forge2D simulation engine will mark it as having fallen asleep so I'm relying on that falling asleep to go, if it's fallen asleep, remove it from the game. Likewise, if it goes outside the screen boundaries, then I'm also going to remove it from the game. Next thing I'm going to do is implement the ability to drag the player. And this is how we initiate where it's going to go and how fast it's going to go there. How do we do that? We're going to implement the drag callbacks. On drag start, the static check is there so that you can't interact with the player once it has started moving. I didn't have this initially, so it was fun. You can have it in flight and then drag it again and have it go somewhere else. I thought that was maybe cheating. So we record the start of the drag. Likewise, on update, we update a drag delta. This will be useful for painting an indication of where the player is going to go, the player's avatar. And on drag end, again with the static check, we rip out the custom painter because once we put the player in motion, we don't need that indicator of where it's going to go anymore. We set the type from static to dynamic. This is actually a relatively expensive call, but we're only doing it once, so that's fine. Just don't set your game up to require this on a regular basis. Apply some force to the player. Now that it's dynamic, it'll start moving. And then give it a lifetime of 5 seconds. So the whole point being, you fling the alien at the bricks, and it gets something done, or it doesn't, and then you get another shot. This is the drag painter itself. It's a custom painter, so for those of you who've done enough Flutter work, you will have either seen this in the implementation of widgets or implemented this yourself for custom UI work. Here's the core of it. We're drawing a line. Also have a should repaint down here. This is required by the type system. It's not actually doing anything because the way Flame works is it repaints every screen, so this custom painter is called every screen, whether you return true or false from here. We need to add the player to the game. So import the player. And this is really why I did the unawaited. If you didn't use unawait, then you couldn't add the player until all the bricks had appeared. I want the ability to have the player on the screen interacting with the bricks as they appear. So that's why the bricks had to be added without awaiting them. And here's how we add the player. Pretty quick, not a lot to it. Just add the player to the world. Again, with the to the world, not to the game. And the game itself, we're going to add an update to. This is where we implement the capability to add the player back. As the game is mounted, whenever the world has no children in it, then we add a player. And I have been told by the powers that be that I should be using query, not where type here, because query is cached. And there's something to fix up in the next version. And if you do that, you'll wind up with this. There's the custom painter, and you can... But wait, there's more. We need to add an enemy, but I'll give you guys 30 seconds to catch up, and then we'll get on with implementing the last step. And I'll sit here playing a game. What, me tidy up by putting everything out of the room? Surely not. Okay, I should probably get on with finishing it. Next step. Okay, so we have one last thing to do. We need to add enemies. Add someone for the player to, beat up on. So what we're going to do, we're going to have a new type. We'll get to this shortly. Body component with user data. That's to do with dealing with contact. So the enemies, like the players, come in 4 colors, but they also come in 2 types. So we're going to have the boss type and the not boss type, and the boss types are obviously wearing suits because that's what bosses do. So we have, and there's the boss wearing a suit. The enemy, the body component with user data, which we'll get to defining shortly, and contact callbacks, which is why we need body component with user data. Most of this super call you've already seen. It's a dynamic body. It has a enemy type. It's a box because they're square, and a sprite component for painting it. Nothing new. But here's where the new part is. We have the contact callbacks. So on begin contact, so this is dealing with the enemy component having something hit it, be a brick or a player, or if it falls and contacts with the ground, this method will be called. So what I'm going to do is take a difference in the velocity between the 2 bodies, and that gives us effectively a vector 2. I'm going to turn that into a length, which turns it into a scalar, and then take the absolute of that turns it into a positive scalar, which I can then interrogate and go, did you get hit with enough force? And if it has, then we can throw it out of the game. This is basically the whole, make sure it's not just a gentle tap. And we have an update, which basically goes, if this enemy component has fallen outside of the screen boundaries, then remove it from the game. So there are effectively two ways to remove an enemy from the game: hit it really hard, or scoot it off the screen. Now here's the body component with user data. I've been reliably informed that this is actually in the library, but I didn't find it while I was building the game. So in an updated version of this code lab, this code will no longer be there, and I'll just use the one from the library. But what this is doing is effectively, it's a body component, obviously. It's pretty much passing everything through to its super. This is effectively a re-implementation of create body with one minor addition. User data equals this. This is required for the contact callbacks to be correctly called on you so that you know what you were hit by. If you haven't got user data registered, then you won't get contact callbacks when you collide with that thing. So if you, for instance, if your ground doesn't have user data set, then nothing happens. Well, it does react with the ground, but you don't get told you've reacted with the ground or contacted the ground. Okay, with that, we need to turn around and replace the what you extend for ground, same with the player, same with the brick, and we're just going to race through adding the enemy. We're just going to add the enemies after we've added all the bricks, and then we're going to make the adding the player to the game a little bit more complicated. If all the enemies have been removed from the game, then we don't want to add a player. And finally, this little bit of code is going to do the most important part of the game, which is putting a you win on the screen once you've gotten all the enemies off the screen. This is, this is the code for adding the enemies. Nothing really new there, which means I get to play games on national television. Whee! Now here's the enemies, and I have to try and get them all off the screen in the next 90 seconds. Oh, one. Let's see if I can get the other two. One more to go. Come on, can I do it? I've only got 60 seconds left to run. Oh, God. There we go. Thank you all.